Okay, continuing with linked lists, in the last video we saw how to define a class that represents a node in Java that stores a data value and a reference to the next node, and then we started working with a node class from the outside like this. And I want to just continue that thought by and also, I should point out, I think this was an important thing we learned at the very end of the last video, and that's that the very last node in the list will have a next value of null, because it can't refer to any particular node, and the only thing that next can store other than a node is the null value. So what I want to do now is give you vertigo by scrolling too fast, and then, okay, I want to draw a linked list, a brand new one, and ask you some questions about it. So here's, you know what, I have found if I, let me draw it in this order so I don't make my circles too small. So again, our data values are going to be strings, but of course we can certainly conceive of linked lists whose data values aren't strings, and we'll just do the traditional ABC linked list here. Oops, node data C, next, and actually the next to the last node, since that will be the last node, will be the null value. Alright, so there's 3 nodes. For some reason this node seems to have a colon. There we go. And, oh, let's have, well, obviously first we need to connect them. Okay, oops, connect them. So this guy's next is this one's next is this one, and let's imagine that we have a variable, and our variable is x, and we want to know what we can do with x. So the first question is, can we get b, the string that contains the letter b, can we get that from x? What would we have to do? Well, if we think back to our node class and we remember that one of the things we can ask a node is get data, then sure, we can ask x.getData, and that should get for us the value b. So the value of the expression x.getData is b. Okay, how about c? Could we get the value c from x? Clearly, if we had this node, we could say that node.getData, and we would get back c. But how do we get this node from x? Well, the value of x is this node. The value in the next field of x is this node. So we want to know what is the value of the next field of the node that x refers to, and that of course is going to be x.getNext. So if x.getData is b, x.getNext is the reference to this node here. Okay, so that's x.getNext, and if we have that node, then, right, the value of x.getNext is itself a node, and one of the things I can ask a node is, get me your data. Get me your data. And in this case, that data is going to be c, which is what I wanted in the first place. So this gives us a sense of how we can get a value from a node, how we can get the value from the next node, how we can get the next node, all that good stuff. How do we get a? How can we get the value a starting with x? Well, you probably figured out we can't get a, right? Because x refers to this node. There's no way to go backwards in one of these linked lists. These are what's called singularly linked lists, in the sense that there is one link, and that one link always propels you forward through the list. We can imagine a linked list that not only does each node store an arrow to the next node, but each node also stores an arrow to the previous node. That's called a doubly linked list, and we'll see about those soon enough. But for now, we can't go backwards in these linked lists. So, alright, I think that that gives us a good sense, but what I want to show you now is that nobody ever draws linked lists in this fashion. It's too tedious. The only thing that's really important about a node is what's its value and where does it go to next. Therefore, the way we usually draw these things looks more like, we draw what's called a box and pointer diagram. And the thing I want to stress about box and pointer diagrams, besides how useful they are, is that a box and pointer diagram is just shorthand for the diagram you see up there. So let's see. Oh, and we indicate the null value by putting a slash through the last box. Okay, so think of each of these boxes represents one of these node objects, and a node stores two things, a data value and a next, and we'll always put the data value in the first part of the box. So that would be, in this case, A, and we'll put the next in the second part of the box, which we show as an arrow coming from that next, coming from inside the next field and going to the next box. One of the things that you may wonder when you look at these linked list diagrams is you'll get confused about the arrow comes from within the box and then it goes to the outside of the box, and you'll wonder things like, well, does it change things if I make the arrow point to the second part of the box? And no, it doesn't, because the arrow doesn't really point to any particular part of the box. The arrow just points to the box, in the same sense that these arrows here just point to the node. It doesn't matter where on the node, where in this green circle here, I point to. And in the same sense, it doesn't matter where on one of these boxes I point to. I can make the arrow point all the way over here, and it's still the same linked list. On the other hand, it is very important where the arrow comes from, right? The arrow is coming from the next field, so it should look like it's coming from inside the second part of this box. Now, these box and pointer diagrams are going to be your friend. From now on, plan to draw a lot of them. Anytime you work with linked lists and you want to plan out how to solve the problem, you're probably going to find yourself drawing these pictures. And if you don't draw these pictures, you're going to be lost, because honestly, I don't know how to solve a linked list problem without drawing box and pointer diagrams, and I certainly don't know how to debug my code when it doesn't work without drawing the pointer diagrams and stepping through my code and seeing how the pointers change to see if I get to see at what point my program is doing something to the picture that's not what I wanted done to the picture. So get very comfortable very quickly with pulling out paper and pen and drawing these pictures whenever you work with linked lists. If you resist drawing the pictures, you'll get the problems wrong every time, and you'll feel like, oh my god, linked lists are so hard. But they're not so bad when you draw the pictures. So be willing to draw pictures. Anyway, the next thing I want to do is work backwards. Now that we have the picture, what's the code that would create this picture? What's the code to create this picture? And the first thing we might wonder is, which of these three nodes should I create first? If I create A first, let's see, A, that's a new node with A, and what next? Well, I would need B in order to create A. So an easy way to do this is to say, therefore, let's make C first. C is easy because I know its next. Its next is null. And I'm just going to store that in a variable. I'll call it C node. Sure, I can do that on one line. Okay, I'll call that C node, and in fact, I'll even add C node to my picture so you can see it. Here's C node, the variable referring to this node with C in it. Okay, now I want to make, well, I should make B next. So we'll make B node, which is a brand new node whose data value is B, and whose next is, well, it's C node. C node. And so I guess in the interest of completeness, we'll draw B node over there. And that brings us to A node. And I guess usually, this is important and I shouldn't have left it out. I deliberately didn't show you the reference to the beginning of this linked list, but normally I am going to have a reference to the beginning of my linked list. And I guess I'll stick with the same color here. So, oops, there we go. So I'm going to have a reference to the beginning of my list, and I think I'm going to call this list list. Okay? So forget about B node and C node for a moment. I want something called list that refers to the linked list that contains the values A, B, and C. That's what I'm trying to create. Along the way, I made these temporary variables B node and C node that'll help me create list. But the real goal here was to make list. Oops, where'd my cursor go? Okay, the real goal was to make list. And list, I can now make. It's a new node with A, and it's A's next, the next for the list for the node referred to by the variable list is bnode. So now I've constructed the entire linked list. And what I want to show you before we conclude this video is we can actually do all of that code, all of that, in just one line if we're clever. We'll just take that very last line and realize that instead of writing bnode, right, look at this variable bnode is only used exactly once, right? So if we could just take all of this that was used to create bnode and put it in place of bnode itself, then we could save ourselves a variable, right? Instead of writing bnode, we'll write new node b c node, just like that. Take all of that and plug it in for bnode. And if I'm clever again, I can realize, wait a second, I don't need the variable c node. I could just write exactly what c node is, and c node is a new node with c and null. And I think I've made a bit of a mess here, so maybe we'll write it. Maybe we'll write it like this. I don't know. I don't know what I'm doing. Who knows what we're doing? I want to write it slightly indented, right? So actually, here we go. You can see that this new node with c and null, that's one of two arguments to this new node with b, right? New node with b and the new node with c and null. Anyway, I think you get the idea. So this is what it looks like to create the whole linked list of one line. New node with a, new node with b, new node of c, and null, and lots of closing parentheses because we opened lots of parens when we were calling all these constructors. And the final observation I want to make in this video is which of these nodes actually gets created first by Java? The node with a, the node with b, or the node with c? Well, it's actually the node with c, right? Because in order to evaluate this, in order to call the node constructor, the outer node constructor, right? In order to call this one, Java first finds the values of the arguments. Well, one argument is a, that's easy, and one argument is, oops, it has to create all of this before it can construct a. And for the same reason, it's going to need to create all of this before it can construct the node with b. So this node gets created first, then this node with b gets created second, and finally the node with a gets created. I don't think it's super important that you understand that, or that you think about the order that they're actually created, but I did want to show you that the order that we created them up here corresponds precisely to the order that they will be created even when we write it all in one line. Great. I'll see you in the next video when we will, I don't know what we'll do. We'll learn more about linked lists, whatever that is. I'll see you there.